Hi everyone, welcome to chapter 6, section 5, more two-step equations, and I'm adding in some more stuff because I feel like it's better because, me and the book, such good friends. Okay, so again, we can review the goal of algebra is to get the variable alone. Okay, and so multiple steps. Last time we were doing 2 steps, we wanted to get rid of any addition or subtraction, meaning combine all of our constants. And anyway, so here's the steps. So now our step 1, when we have multiple steps, is we want to simplify. So we're going to simplify each side as necessary. We're going to simplify. So we want to get down to where we have all the constants. All constants are on one side, and all variables, or at least the variable that you want to solve for, on the other side. And really, that kind of takes away our step 1 from last time, because the step 1 from last time was moving the constant over to the other side with the other constant. So this basically covers that. So if you have, anyway, I will do some examples, and then we can do this step 2, which is undo any multiplication. Okay, so you can add and subtract variable terms just like we add and subtract the constant terms. And I will show you that in a minute as well. Now, the book assignment primarily focuses on needing to distribute, which is part of our simplifying. Okay, there's actually 2 ways to do it, and I'll explain when I like one way versus the other way. Because there's definitely situations where you can't do what kind of feels like the easier way right now. Okay, so what we're going to do is you're going to see something like this. 3 times x minus 6 equals 12. Okay, so 3 times x minus 6. Again, 2 ways to do this. The first way, and this is the general way, this is the way. How very Mandalorian of me. Okay, what I would recommend doing, because it works every time, is distribute that 3 through, so we can get rid of the parentheses and do our solving. Okay, so 3 times x is 3x. 3 times 6 is 18 equals 12. Okay, and then we can go ahead and do what we did yesterday. So we want to combine our constants and need to move the 18 over to that side. So plus 18 plus 18, and I get 3x equals 30. And then divide by 3, x equals 10. Okay, now let's put this in here for x and see if it works. If we put 10 in here for x, we get 10 minus 6. I'm going to do this. So 10 minus 6 is 4. 4 times 3 is indeed 12. So we did it right. I wasn't even going to put a box around it until I did that. Okay, that's the way that will work every single time. That's the way I feel like you should do it. What might make it easier just on today's assignment is we can divide out that 3 first. So basically we're doing the division first. So I'm going to write this down again. Okay, now the only reason why we can do this is because this is the only thing happening on this side of the equation. Okay, if we had other things being added or subtracted, this would not work as well. But for the way they've written these problems, this is a way that we can do this. So, because this 3 means multiplying, right? So to undo that, we're going to divide that whole side by 3 and divide this whole side by 3. So those go away, and we're left with x minus 6 equals 4. And then we'd add 6 to both sides, and x equals 10. Okay, so we got to the same place, took one less line of writing, but like I said, this only works in this specific instance, whereas distributing works every single time. But it might make things more difficult, particularly if we have a fraction on the outside. So when that happens, like, I would recommend doing the books method just to make that a little bit easier. Let's do some more practicing of what you will see on this assignment, and then I kind of want to show you the generalized simplifying multiple step problems. Okay, so I'm going to do it both ways again so you can see it. Again, my preferred method, so we've got 2 times x plus 4 equals 20, and we're going to do this 2 times. Okay, again, my preferred method, because it just works every time rather than just one specific time, is distribute that 2 through. So you do 2 times x, which is 2x, and 2 times 4, which is 8. And now we're going to move our 8 over, so minus 8 minus 8. And we get 2x equals 12. Divide by 2, x equals 6. Okay, put 6 in there. 6 plus 4 is 10, plus 2 is indeed 20. All right, so if we do the books method, which only works when there's nothing else happening on this side of the equation, then we do our division first. So divide by 2. We get x plus 4 equals 10, minus 4, x equals 6. So again, works both ways. This just only works in this specific instance, whereas this one works every time. Now, when it's a lot easier, this is when I would recommend using the books version rather than my version, at least on the book assignment for today. And that's when you have a fraction on the outside of your parentheses. So 2/3 times n plus 6 equals 10. And again, I'll write this 2 ways. 2/3 n plus 6 equals 10. Okay. So here we go. My distributing method, we would do 2/3 n plus, remember when you multiply fractions to whole numbers, we put it over 1. So 2 times 6 is 12. And then it'd be over 3. That actually reduces 2/3 n plus 12 divided by 3 is 4. Okay, so there we are. And now we're going to subtract the 4 from both sides. And we get 2/3 n equals 6. And then remember to get rid of our fraction coefficient. We're going to divide, which is the same thing as multiplying by the reciprocal. Okay, those turn into 1, so they go away. We get n equals 2 can go into 6 3 times. 3 times 3 is 9. So it makes us have to deal with fractions, and sometimes this one doesn't end up being divisible to make a whole number, and so I recognize that can be tricky, but you know what? Fractions exist. It's just part of life. Okay, what the book would have you do is get rid of the fraction first. And again, the only reason we can do that is because there's nothing else on this side of the equation. I'm trying to emphasize that a lot. This works for right now. It doesn't work as well in general. Okay, so the 3/2 times 2/3 turns into 1. We're left with n plus 6. And then over here, 2 goes into 10. 5 times 3 is 15. And then we subtract 6 from both sides, and n equals 9. So we got to the same place. When you have a fraction outside your parentheses, that method is probably easier, I can totally accept that. Okay? When we have decimals on the outside, either method works. So 0.75 times 6 plus D equals 12. Okay, so this one works either way. I'll write it down, 0.75 times 6 plus D equals 12. So if we distribute this through, 0.75 times 6 is 4.5 plus 0.75D equals 12. Subtract 4.5. 0.75D equals 7.5. Then we divide by 0.75, divide by 0.75, and D equals negative, oh no, just 10. I was doing it backwards on the calculator. Okay? So on this one, it might be easier to get rid of the decimals first, just like we got rid of the fractions first as well, but the distributing method still works. That's the one that works every time. Okay, if we do it the book way, we're going to divide by 0.75, divide by 0.75 first, left with 6 plus D equals, and then 12 divided by 0.75 is 16. Then we subtract 6 and subtract 6, and D equals 10. So that gets, we don't have to deal with quite as many decimals if we divide first, which is totally fair. But also, whatever. It is what it is. Okay, couple story problems, and then I just want to show you kind of ultimate solving equations, stuff. Alrighty, so this says Jamal and 2 cousins received the same amount of money to go to a movie. Each boy spent $15. Afterwards, the boys had $30 altogether. Write and solve an equation to find the amount of money each boy received. There is a lot going on in this story problem, okay? First of all, we have Jamal and 2 cousins. This gets confusing right here. People will just see the 2 and go with that, but how many people are we dealing with altogether? That's going to be 3 people we're dealing with altogether, okay? Now, that's the number that's going to go on the outside of the parentheses. Inside, because it says each boy, so we're talking about what one of them does, spent $15. Okay, we're trying to find out how much money they received. I'm going to call that M, how much money they got, and then they each spent $15, and what they had left is $30. Okay, so that's kind of the pattern of what the story problems out of the book will look like. Okay, so I'm going to move that over to my other paper. So 3 times M minus 15 equals 30. Okay, now again, either method works, just to be time efficient. Because nothing else is on this side, I am going to divide by 3 first, just because that will make nice small numbers. Amount of money minus 15 for each boy should come out to be 10. Add 15, and each boy got $25. Okay, and that's what the question asked for. Okay, one more story problem, and then I want to show you some other simplifying math stuff. All right, this story problem says Mr. Singh had 3 sheets of stickers. He gave 20 stickers from each sheet to his students and had 12 total stickers left. So again, this one is going to be very similar to the other one. 3 sheets of stickers, that's going to be your number on the outside of the parentheses. And then he took away 20 stickers from each sheet. So we're going to have 3 on the outside, and then we're going to have, let's see, They're both S's. We'll call it K because there's a K in stickers. Okay, so we'll have K minus 20, and then the whole thing is going to equal 12. So let's write that down. 3 times however many stickers are per sheet, because that's what it's looking for, is how many stickers are per sheet, minus 20, and that equals 12. Okay. This time let's distribute through. 3 times K is 3K. 3 times 20 is 60. We're going to add 60 to both sides. And 3K, that's an X, Sanford, good job. 3K equals 72. Divide by 3, divide by 3. K equals 3 goes into 7. 2 times with 1 left over. 3 goes into 12 4 times. So there's 24 stickers per sheet. All right, math. So that's basically what you need for the book assignment. But for life, I just kind of want to show you. So we're going to do an extra number 7. All right, so I want to show you what I mean by simplifying before we do anything else, because we can, and this is what happens when I make up my own equations. So if the numbers turn out wonky, I apologize. I'm going to have 3x plus 7 over here and set that equal to 5x minus 3 on that side, okay? You can have variables on both sides and constants on both sides. And what I meant by my steps, the first step we want to simplify. Sometimes, let's even step it up a notch. We could do 2x plus 3x plus 7. Okay, so you see we've got some simplifying to do on each side. Then we need to bring our variable terms together and our constant terms together, and then we can do our division, okay? So step 1, simplify each side. And I didn't write that on the other steps. Maybe I should have. Simplify each side. Okay, so that means I'm going to add those two x's together. That's the only thing we need to do. 2x plus 3x is 5x plus 7 equals 5x. Oops. How about we make it? See, again, this is what happens when I'm making up my own numbers. We'll do 4x. 4x plus 3x gives us 7x. This way our x doesn't just go away. And then 5x minus 3. Now we want to combine like terms across the equal sign. Combine, I can spell. Okay, and we'll practice this some more later. Like I said, the homework is mostly going to be focused on what we did up there. Okay, just to have a positive x, I'm going to bring this 5x over here by the 7x. And we'll move it just the same exact ways we've been moving our constant numbers. And so if we just subtract 5x from both sides, see, 5x minus 5x gives us 0 x's, which is 0, which doesn't change the value. Then over here, 7 minus 5 leaves us with 2x. We still have the plus 7, and now we just have negative 3 on that side. Now, this is where we've been before, right? We need to take that constant over there, so negative 7, or minus 7. And we're left with 2x equals negative 10. And now we divide by 2, x equals negative 5. All right, so that kind of gives you a taste of where this is going, where it can go. All right, good luck with this, and have fun algebra-ing. Ha ha.